basically, you're just rearranging it, so put it in this form. So y is now CA over CA naught. And this is the final form that it asks you to solve for. So that's like the first of 3 questions that I kind of asked in part C. So then the next part of the question was to calculate the maximum concentration of species R that can be produced for m equals 0.5. So now that you have an equation for CR, to get the maximum, you have to take the derivative, set it to 0. So, and for that, it's easiest to keep it in terms of m and y rather than convert it back to CAs, but you can do it either way. So this is what you get. You then want to rearrange and solve for in terms of y. So we get y equals some function of this. And then you know that m equals 0.5. So that's how you solve for y, and then you go through and solve for everything else. So that's what we're going to do.
Quick question.
Yeah.
Just for math's sake, where you're standing right now, right in front of you, it says negative m plus 1. Should that be negative parentheses m plus 1? Because, like, I'm just imagining, because the math checks out if it's negative m parentheses m plus 1.
Yeah, I think it might be. There's something weird going on with negative signs.
On your integral to the left where you have dca times, there should be a negative.
Over here?
Yeah, I think there's supposed to be a negative plus that, because you just did like
Yeah.
e to the ln, so
Yeah.
negative 1 in front of that.
Because it's negative 1, you're missing the negative.
Yeah, I think I missed a negative sign there.
Okay, that checks out.
Yeah. So I think, so I'm pretty sure that is the right form. I might have messed up negative sign here somewhere, because that's getting easier, but I'm about to erase it, so.
Okay.
All right, so from here you can just factor out the CA naught over m minus 1. Gets you 1 minus n. Y. So you can just divide this over by 0, and then rearrange it m y to the m minus 1 equals 1. So you can rearrange it to get y in terms of only m. So it's y equals 1 over m to the 1 over m minus 1. And then n asks you to solve for the maximum concentration at m equals 0.5. So you just plug in 0.5 here, and you get y equals 0.25. You can then calculate your CA. So CA equals C naught times y, which is, since C naught is just 1, it's just 0.25. can then also calculate your species concentration of R. So CR equals so from over here, CR equals C naught over M minus 1, Y to the Y minus M, or Y to the Y minus Y to the M. So that's 1 over 0.5 minus 1, basically just plug in everything. How do you know what M is? It tells you in the problem, it says solve for use when M is 0.5.
Oh.
So calculate the maximum concentration of species R that can be produced from M equals 0.5. And then the corresponding conversion of species A. So yeah, it gives you M equals 0.5, you solve for Y, and it gives you CA naught at the beginning of the problem. So for CR, you get 0.5. Moles per liter. And then to solve for the conversion, you go back to the original equation, species balance, so CA equals C naught 1 minus X. You know your CA is 0.25, you know your C naught is 1. Solve for X, you get your X equals 0.75. So that wraps up part C. It was a lot of math, but pretty simple. Just have to realize that to get the maximum, you have to convert for the derivative instead of the 0. And then the final part of this question is part D. Express the species A mole balance equation in terms of only CA and known parameters. So for this, you have to go back to the very start of class where you define extensive reaction. Use extensive reaction. So instead of thinking about it in terms of case right here, you can do, you'll have an extended reaction for reaction 1 and a different extended reaction for reaction 2. And then you can just write out the moles of A, B, R, and S. So Na is equal to Ne naught minus the extended reaction 1. NB is equal to Ne naught minus reaction 1 and extended reaction 2. Since you don't have any R initially present, it's going to be reaction 1 minus reaction 2. So this part can be a little bit tricky after you define these. So you're going to want to rearrange Na and Nb in terms of extensive reactions and initial moles. So you know that your rate of change of concentration A with respect to time is negative K1 CaCb. So you know what Ca is pretty much, but you don't know what Cb is. So you start off by recognizing that extended reaction 1, just rearranging up here. extended reaction 1 is equal to Na naught minus Na. And then you can say that NB is equal to the Na naught minus extended reaction 1 minus extended reaction 2. Plus extended reaction 1 minus reaction 1, extended reaction 1. So this will just get you 0. But when you add it to here, you can rearrange. So NB equals Na naught plus extended reaction 1 minus extended reaction 2 minus 2 extended reaction 1. You then know that this together, you can substitute in for NR. So you can rearrange this so and you solve for, you just rearrange for extended reaction 1 here. So you can put this in terms of Na naught and Na. So you have minus 2 Na, or Na naught. So NB now becomes Na naught